Okay, gang, so I have another K7000 here on the bench, and I don't normally film the 7000s anymore unless something very interesting or particular is happening, because I got so many videos and I've covered everything you could possibly think of under normal circumstances in the 7000 series. But in this instance, I got this in for repair. It was in, I don't think the person that sent this in to me really told me what was wrong with it. I can't recall. But some quick inspection found that the R101 resistor was the wrong, it was the right reading, but it was a giant, what did I do with it? I don't even remember what I did with it. Oh, right here, hang on. This is what was installed in R101 position. It's a 6.8K ohm ceramic resistor, so technically this would work, but it's not correct for what should be in there. There it is. 6,800 ohms, so 6.8K. So this was in there where R101 should be. So I went ahead and put the correct R101 in there, and I cleaned up the solder joints, which are notoriously being bad on R101 R89. I've covered that 100 times. So this odd resistor was in there, so I got the correct type and everything in there. And then also through the rest of my inspection, I found that the C38 width cap was completely shorted. Dead short, 0.0 ohms across C38. So something completely zapped out the width cap. So I went ahead and replaced that. It's that guy right there next to the width coil. So we had a faulty or shorted C38. We had the incorrect type of resistor in R101. Got those two components replaced. After that, I did the reflow inspection, or reflow, inspection, everything, and everything checked okay. Found nothing else wrong, so I put it on the tube and fired it up. And I should say that this was already reworked. Somebody had already installed a rudimentary cap kit. I say rudimentary because there are some caps that weren't changed, and a flyback in an attempt to try and fix this, and some rudimentary reflow. So all the kind of rework had already been done. But everything that I've discovered was just that resistor and that cap being shorted, and everything else checked okay. So I went ahead and turned it on and fired it up, and it works. However, what's interesting is when I was adjusting the flyback, if I turn up the flyback here, I'm turning the screen pot on the flyback, and it goes haywire. I thought, now that is very odd. So I checked the B+. Look at the B+. 100 volts. Should be 130, and it should be stable. And look at what it's just sitting here going crazy like this. So the B+ on the K7000 is non-adjustable. It's regulated by a regulator. And you connect your positive lead to that point right there on the B+ resistor, and negative lead, you just go to ground. I go to the DAG ground here. But B+ is only 100 volts. Now, watch what happens here if I adjust the screen pot. Am I going to be able to do this here? I don't think so. Let's just, can I move this to the other side? Here we go. Now I'm going to adjust the flyback here and watch the B+. I'm going to turn it up. 93 volts, 90 volts. The image is stable, and we have the raster lines, but 92 volts? We've got a severe B+ issue. And if I turn the flyback completely down, right now the flyback is 100% off, and it's 110 volts. Turn it back up to where I get a decent picture, and it's 106 volts. So you would look at this and think nothing's wrong. And if I hadn't adjusted the flyback, I might not have discovered this problem, because I don't normally check B+, because it's regulated. There shouldn't be any B+ problems. But I happened to discover this because I went to adjust, I always do the brightness contrast procedure. So you turn brightness completely down, contrast completely down, turn the flyback up until you get the raster lines. So let's see, roughly there, and then turn it back down until they just go away, roughly there. And then we turn our brightness back up until the background is no longer black. And I don't even get to that point. It's still black. So I thought, well, that's weird. And then when I went to adjust the screen pot up a little bit more, that's when I noticed the B plus was, well, I know something was wrong, so I hooked up the meter and found B plus is only 105. So I'm gonna turn this off. Something is very wrong in that B plus circuit. I don't know if it's the B plus resistor. I checked it, it was 180 ohms, so that's fine. So the resistor itself isn't at fault, but I wonder if the regulator is simply failing. It does check good. It does have the 0.5 voltage drop across pins 1 and 4 when the resistor is out of circuit. And it does have the 0.150 voltage drop across 1 and 4 when the resistor is in circuit. And it's the correct 130, STR 130. So it should be a 130 volt regulator. So something is very wrong. I don't know if there's something else I missed because this was dead short, which I'll show you later. So I don't know if something else is wrong or really what's going on, but yeah, I think that regulator is probably just simply faulty. So let's get this off with the tube again, take a look and test that regulator one more time and throw a new one in and see what that does. Okay, so we got the chassis back off the tube and cameras on the overhead, but so yeah, like I say, someone has already done a cap kit on this, and from what I can tell, they didn't really change out the bipolar caps, which no one ever does. And but I think for the most part, the rest of them have been replaced. And like I say, it is very clean. But one thing I did find, and all this rework, was that resistor for R101 was ceramic, but I got that changed out. I also got the rest of the reflow done, and I got the normal repairs done to these things that I do. I took the solder off of the joints, and they were of course oxidized beyond belief. Actually, this connection here for R89 had popped off the joint. The whole joint had popped off the pad because the pad was so oxidized that the solder wouldn't stick to the pad anymore. So that was probably the main reason why it wouldn't even turn on, I imagine. And then the C38 width cap, I haven't cleaned the flux off yet, was dead short. So I got, the only thing I found, like I say, was this cap dead short and that wrong resistor. So I got those replaced, did the reflow inspection, found no other components faulty. So we powered it up and we had that issue we just saw. Now, what in the world could cause that? Well, it's probably just a faulty voltage regulator. So we'll check that out here shortly. But I do want to show, I hate this one with the stupid extra. This type of remote board, I don't understand, because you can actually take all these wires off. You can remove this completely. Take all these wires off, take this, throw it in the garbage, and add a V position pot and an H position pot, and this will work 100%. I don't even understand what the purpose of this is, because there's a brightness pot right there, and there's an extra brightness pot right here, black level, black level. Why are there two? I don't understand. I never really figured out and understood what the purpose of this little extra secondary remote board is. Because like I say, I have removed this. You can take all these wires off the chassis completely, take this entire thing and throw it in the garbage, and just add the horizontal position and vertical position pots back onto the board, and it'll work 100%. So, I don't know, but it's not mine, so I'm not going to do that. But the horizontal width cap here, let's get rid of these alligator clips. We'll turn this to continuity mode just to show you here, and 0 ohms. .1. I've never, I can't recall one that was so dead short like that before. And C38, of course, is the main width cap right there, and you want to check that always when you do your. I've covered this so many times in so many 7000 videos, but the components you want to test are R103. All your rectifier diodes, R104, R101, R89, R97, R88, with this guy in here, R96 over here, C38, D18, and your voltage regulator and your HOT. And those are all the components in the power circuit you need to test if your fuse is open or is blowing, or there's some other component that's bad. So in this case, I found C38 completely shorted, but I didn't find anything else that was bad or out of spec. And if you test the resistor, it's still a bit warm, so it may not be exactly 180, but if we test it, it reads 177. Oh, you can't see. Hang on. So that right there tells me that the resistor is within spec. it tells me the voltage regulator is not shorted. And I really don't know. I mean, the 19-inch, the B plus resistor is about 220. Do I have one that I can show? Not offhand. Not offhand. I have one here. That's a 25. Well, I don't have a 19 available, but see, here's a parts chassis, another 25. And if we test that one, see, there's 187. So 180 ohms is about what it's supposed to be. So the resistor itself isn't out of spec. And if the regulator was shorted or open, well, I guess it could be open, you'd still get 180 ohms. But if we go to diode mode and we check this, you should get a 0.150 voltage drop because you're going through the regulator and back through the resistor. So it should be like 1.15, yeah, 0.149. So that's a good reading. You can also go directly to the regulator. Now this is the type of regulator that is the wide fat one, which in this case you go to pins 1 and 4, but on the tall skinny one you go to pins 3 and 4. So I believe negative on 1, positive on 4 in diode mode, and we get, yeah, 0.148. So that's a good reading. That's a reading that you would expect to see on a functioning good regulator. Now, the question is that problem that we're experiencing a possible bad filter cap? Is it a possible bad voltage regulator? Is it a possible bad flyback? This has got a white wire on it, and it doesn't have the arcade parts and repair sticker on it, so I'm wondering if this came from like Arcade Shop or something. I don't know. You know, I'm always weary of these replacement flybacks that have the white wire, but it is functioning, it does work. So I don't know if it's the flyback causing that problem. The easiest thing to do to find out if it's the regulator is we can just remove the collector of the HOT. I'm going to turn my extractor on here. We can remove the collector leg of the HOT, which will essentially turn off the horizontal output section, the horizontal drive. And we can do a light bulb test to determine if it's a voltage regulator problem or a flyback problem. So let's grab this and bend that leg out. Okay, so with this leg of the HOT out of circuit, you can safely power up the chassis without a picture tube and run your light bulb test. So, oops, sorry, I didn't mean to hit you there. And we want to go to continuity to make sure that that pin is not actually touching the pad. So here's the pad. Let's touch the pin. Okay, pin is not soldered to the... Now, if you want to do this yourself and you're scared of, you know, causing a problem or shock on yourself, you can just take the HOT out completely. Take the HOT out completely and you'll never have to worry about possibly energizing the horizontal section and turning the flyback on and all that and getting shocked. So if you're uncomfortable with just taking this pin out, then just take the whole HOT out. You don't got to worry about anything, but I'm comfortable doing it this way. So if we touch the pad, you have continuity. If we touch the pin itself, nothing. So we have successfully desoldered it. It's not touching the trace or the pad, so that's good. So now we can fire this up and do a light bulb test without fear of energizing the horizontal section and firing up the flyback and getting zapped by the flyback. So let's do our light bulb test here. We will grab a couple of these and we'll go to volts DC and we'll hook up this and we'll go to the output here on the resistor and hook up this and grab our 60 watt incandescent light bulb and hook that up to here and hook that onto ground. Okay, and let's grab power, plug it in, plug it in. All right, so let's see what we get on this reading here. 1, 2, 3. Oh yeah, 73 volts. We have a regulation problem. So that right there immediately tells us that it is not a flyback problem. It is very likely not a capacitor problem. 74 volts, that should be 130, give or take. So something is very wrong here. So I am 99.9% positive that we have a faulty voltage regulator. So let's go ahead and, I don't know if I want to, yeah, let's just go ahead and disconnect all this stuff here. So that is a very quick and good, easy troubleshooting tool at your disposal to help you determine if you have a problem just like this, a B+ issue, how to determine if it's a power supply issue or a horizontal drive issue. So let's go ahead and, holy crap, that resistor is super warm. We only ran that for what, 20 seconds? 20, 30 seconds, and that is super hot already. Not super hot where I can't hold it, but it shouldn't be that hot running just for 20, 30 seconds there. That's, yeah, absolutely. There's something going on in this power supply section. So let's go ahead and, if I find my tools here, I'm so disorganized. Okay, let's go ahead and remove this regulator. Regulators, remove. Okay. Well, now I need to find that nut that I dropped. There it is. So we will remove the reflow solder that I already put on. That's okay. And I think that will get us out of there. All right. Okay. Now I wonder, what does this read out of circuit? It's probably going to be the same, 1 and 4. Nope. Yeah, 0.48 voltage drop. But I don't think that's right. 1 and 2 also have the voltage drop. Let's grab a brand new one. Here's the tall, skinny 130s, which would be pins 3 and 4. Okay. Lots of parts in here. What are these 130s? There's some 130s. All right. Let's grab one out of here. And let's see if this reads the same. I could be wrong, but I don't recall 1 and 2 having that, but let's see. Yeah, I guess so. It does read differently, 0.5. 0.5. So this reads 0.5. Yeah, it's weird. Well, it doesn't read bad. It does read a little bit lower than this one, but it does read the same, so I'm starting to wonder if maybe it's not the regulator. But let's put another one in, because you can have faulty components that read correctly, and the fact that we know that it's something in the power supply that's causing this, is it an out-of-spec component? Well, no, you know, now that I think about it, let's test 270 again. That's fine. I'm sorry, not 270. R97 is supposed to be 270 ohms, so that's fine. R89 should be 3.9. We get 3.9. R101 should be 6.8, but in circuits more like 5.5, 5 I should say, yeah, 5K. R96 should be 1.8. R88 should be 1.8. R104 should be 15 ohms. R103 should be 2.7 or so, 2.7. Yeah, I mean, all that stuff is good. So it almost has to be the regulator or the resistor. I mean, let's throw this new regulator in there and just see what we get. It's never easy trying to do this with these wires in the way here. Because it's hard to get this stuff to line up here. Okay, that's in. In like Flynn. Okay, should be able to solder this in and give it a try here again real quick. Nice, quick, easy swap. I say it's never easy to get it in there, and I got it in there relatively easy, but sometimes it's not easy. So I'm holding on to the screw heads with my fingers, and you can just tension these down. You don't need to tighten them down like a madman, just snug is all you need. Snug is all you need. And you can see here this replacement C38 that I installed is not shorted compared to our other ones, so yeah. I don't even think C38 is in play with that HOT desoldered. So with that done, let's solder it back in before we forget. And of course we'll clean it up later once we're done and get this working. We'll go through and clean all this flux up and get everything fixed. And if it still has the same issue, at least we have eliminated the regulator as our issue. So there's that. Let's make sure our HOT pin didn't get moved over or doesn't read to the pad anymore. Nope, still good. Okay. All right. Actually, I don't think that's the collector. I think that actually is the base. It's been so long since I've looked up the spec sheet. I could be mistaken, but regardless of whether that's the collector, emitter, or base, I'm pretty sure it's the base. Regardless of what it is, just that middle pin. That's the one you want to worry about there. So, okay, with that done, let's try again. I'm not going to hook the meter up here. I just want to see real quick if it's any brighter. I could tell immediately if it's brighter that it's fixed or not. Then we'll hook a meter up. Okay. Oh yeah. We're in business. Or as they say, bidness. We are in bidness. Okay. Yeah. Continuity. Okay, volts DC. Here we go. There we go. 128. You little rascal. You little rascal. So, there we go. 128.3. So, yep, bad regulator. So there you go. Even though it reads correctly, under load, failing. All right, so that's two actual faulty components. So let's get this back on the tube and try it again with the new regulator in there. Okay, so here we are back on the tube, ready to test again. We'll turn our TPG on. Okay, so meter is set over here, ready to read our B+. Again, it hooks up to right there and goes to ground. So volts DC, all right, here we go. 1, 2, 3. Well, what do you know? 130. Oh, you little rascal. Okay, so good B+ now. And our image is much wider and taller, which you'd expect with going from 100 volts to 130. So we'll turn our V size down a little bit, right about there. Width, H position, I have to use the little board here. And I'll put it roughly there. It's good. Do we have RGB? Oh yeah, color bars look great. Of course, that's the 2 really, but yeah. So there you go. This thing had a shorted C38 width cap and a faulty voltage regulator. So that's about it, and I've covered everything else on these, you know, ad nauseum in 1,000 other videos for the 7000. But this one was a little troublesome. Wanted to document. So whenever I come across these, I actually work on a lot of these that I don't make videos on because, like I say, I've done so many videos on them, and I really only want to cut in and do a little dedicated video on these if there's some type of anomaly like this that I haven't shown before or is really worth showcasing. So that was the case here. C38 was shorter, which I've talked about on a number of other videos, so that wasn't out of the norm for things like this. But that regulator not reading incorrectly or reading properly but failing under load, not being able to provide 130 volts, that was a very interesting little anomaly. So I wanted to showcase that, and I was confident that was the issue, but at least now you know how to isolate the power supply from the regular chassis, regular rest of the chassis I should say, the horizontal output side, to troubleshoot something like this exact problem. So that being said, thanks very much. Something down and dirty, nice. The last half a dozen videos or so have been like an hour, hour and a half, 2 hours, so it's nice to have a down and dirty, quick and easy one for once. So yeah, well, all that being said, thank you very much again. As always, I hope you enjoyed watching the video, and I hope you learned something. Make sure you like, share, and subscribe. Comment down below if you think this was interesting. Otherwise, thank you very much, and we'll see you next time.